Okay, this is number 1 on homework 3 about optimization. So optimization seems really complicated, but it's no more difficult than finding a first derivative or a second derivative and then knowing how to set that equal to 0. The first problem is asking for the intervals of concave up, down, and points of inflection. Given this equation, y equals 4x cubed plus 21x squared plus 36x minus 20. So we know concavity is involved with the second derivative. So we're going to find that first by finding the first derivative. And then the second derivative will be equal to 24x plus 42. Now from here, you have to set that equation equal to 0. These are big numbers, but like not that big, they're pretty simple. If you wanted to factor out a 6, and then you could do that. Or you could just solve it by doing 24x equals negative 42. Either way works, it's just algebra. And then you solve, you get x equals negative 7/4. Either way you do it. Now from here, you have to make your sign chart. Make sure to label it double prime. We only have one x value, so that's the one we're going to put on the sign chart. So from here, we're going to find out if value is less than negative 7/4, our concave up or concave down, and value is greater than our concave up or concave down, which is as easy as saying when that value is plugged into the equation, is it positive or negative? So we'll start with a point less than negative 7/4. We can just use -2. And then you say 24 times -2 is negative 48, which is less than negative 42. So this will be negative. And then greater than, let's just use 0. 24 times 0 is 0. 0 is greater than negative 42, so that will be positive. So now from that we can conclude that this graph is concave up when x is greater than negative 7/4, concave down when x is less than negative 7/4, and the point of inflection, which can be abbreviated to POI, is at negative 7/4. Okay, this is number 2. So it is slightly weirder. However, the process we go through to find the concavity, or the intervals of concavity, will be the exact same as the first problem. So we need to find the first derivative of 5 minus x to the power of 1/3, which again, power rule to be negative 1/3 x to the negative 2/3. And then I'm going to keep the negative exponent just for ease. You could put it on the bottom and then do the quotient rule, but why do that when you can just do power rule again? Negative 2/3 times negative 1/3 equals 2/9 x times exponent, or to the power of exponent minus 1 is negative 5/3. So now that we have our second derivative, I'm going to go ahead and, well, from here I'm going to move the x down to the bottom of the fraction, just because that's easier to work with. So y double prime equals 2 over 9x to the negative 5/3. So now, just like the last problem, we're going to set that equal to 0 to find our point of inflection. This should be a positive because it switched numerator to denominator. that equals 0. So I look at that and I realize that if you have a constant on the top, you can never have it truly equal 0. If you have 2 over any value, it's still going to equal a value and not 0. So we can't set it equal to 0, but we can make it undefined. So making this value undefined is fairly simple. You just say x equals 0. And then at x equals 0, this value becomes undefined because 9 times 0 to the power of 5/3. 0 to that power is 0. 9 times 0 is 0. 2 divided by 0 is undefined. So that undefined point will be the one that goes on our sign chart. And now we need to find, is the graph concave up, or is the second derivative positive or negative for both less than and greater than 0. -1 is less than 0, so I'm going to use that for this side. -1 to the 5/3 is negative times, that just makes the whole thing negative. Same thing, when x equals 1, it's positive. So then you can fill that in and write your intervals, which will be 0 to infinity is concave up, and it is concave down from -infinity to 0. And then this graph, I'm not a great artist, but will look something like this, where that's going to be a hole at 0, because the second derivative is undefined at x equals 0. However, the concavity still switches, and you can't have a point of inflection if there's not a point. So while yes, it does switch from that at that x coordinate, it is not a point of inflection. So your final answer will just be the concave up, concave down on those intervals.